So the second theorem of circle geometry states that the circle with center O and arc AB, all right? So we will have center A and arc AB. So if that circle has center O and arc AB suspending AOB at the center and ACB at the circle, then we are to prove that angle at the center is twice angle at the circumference. Okay, so in this scenario, you will either be given this circle, this diagram, or the third one. Any of them might pop out. So when that happens, if you get this one, you are given angle at center, which is angle O, suspended by arc AB. You are given angle at the circumference, which is angle C. It's also suspended by arc AB. So you need to prove that here O is 2 times C. You're going to construct that OC, extending it, and then you will name the one angle 1, 2, 1, 2. If you are given this one, you are going to still construct CO and still name 1, 2, 1, 2. Just remember to extend. And then the third one, you will still have an angle at center, angle at circumference, both suspended by AD. You will then also construct OC, which is extended, and have 1, 2, 1, 2. So remember this one also, it's angle at center with angle at the circumference, and both of them are suspended by AB. So you're going to get one of those. Just remember your construction. And then the proof is the same for 3 of them, just different diagrams. All right. So let's focus on one. So let's say now then you are given this with points A, B, and C. So just remember, when a point touches a circumference, we say it's concyclic. Just remember that term. So we have 3 concyclic points. So that means we have points that touches the circumference. Points A, B, C. And in this circle, we have center O. This center O is suspended by arc AB. We have the point at the circumference B, which is also suspended by AC. So we need to prove that angle AOC, angle AOC is 2 times angle. That's what we have to prove. We need to prove that angle AOC, this angle is equals to 2 times angle ABC. Angle at center is twice angle at circumference. So where do we start? Always a construction. You redraw the whole thing, and then we're going to construct. Our construction is going to be by joining BO. Just remember to extend it, okay? Remember to always extend the construction, creating angle O1 as well as angle O2. And in this case, we can say we have angle B1 and angle B2. So now the knowledge of previous grades that we need now is that of triangles. We know that an exterior angle of a triangle will be equals to the sum of co-interior angles. All right. We also know that an angle that has 2 sides that are equal will then give us equal angles. All right, we call that an isosceles triangle. That's the knowledge from previous grades that we're going to make use of. All right, so in triangle, let's focus in one triangle first. In triangle ABO, ABO, what do we notice? A triangle. There's an exterior angle O1. Okay, so that angle O1 is then equals to this angle A angle A plus angle B2. Okay, here is my true. Let me just write it again so that it's visible. Okay, I constructed, my construction was joining OB so that I can have angle B1 and B2 this side. Okay, so this exterior angle is this angle plus this angle. And then our reason is that this is an exterior angle of a triangle. Exterior angle of triangle. Always remember to give reasons. A statement without a reason is not valid. In circle geometry, you will not get your mark. All right. And then in the same triangle, we see that OA is equals to OB. Why are those equal? Why are we making such a statement? Because OA is a line from the center to the circumference. OB is the line from the center to the circumference. That means both of them are radii, because both are from the center to the circumference. And we know that radii of the circle are equal. Radii. So that means triangle ABO is an isosceles triangle. So if this side is equals to this side, that means the opposite angles are equal. Therefore, angle A is then equals to angle B true. Okay, our reason in this case is that we have angles that are angles equals to opposite sides. All right, and then do notice that we said angle A is equals to B true. So from here, we can substitute our angle A for B true. So then we can say O1 is equals to, remember we said A is also equals to B true. Okay, so we can substitute A for B true. Then we have plus B true. B2 plus B2 will give us 2B true equals to 2B true. And similarly, in the other triangle, we're going to do the same proof. Since we're going to follow exactly the same steps, there isn't a need to go and write them down. We can just say similarly. Similarly means that everything up applies. So we will say similarly, Okay, what will be similar then is that O2, after following all those steps, will also be equals to 2B1. Okay, if O1, we've proved that it's equals to B2, we can prove using exactly the same steps that O2 is also 2 times B1. Okay, we use the word similarly because we're going to perform exactly the same steps, so there isn't a need because they are already there. So let's add these two together. Let's add O1 plus O2 angle O1 plus angle O2 will then be equals to O1, we said it's 2B2, 2 times angle B2, and then we said O2 is 2 times angle B1. All right, finishing it off, angle O1 and angle plus angle O2 are angle AOC. They make up angle AOC. So this is angle AOC which is equals to, we taking 2 out as a common factor, then we are left with B1 and B2. So B1 and B2, they make up angle ABC. So this is 2 times angle ABC. So we have proved that angle at the center of the circle is twice angle at the circumference of the circle. A very important theorem. We're going to use this theorem to prove others, and you will find it in many exercises of circle geometry. All right. So for theorem 3, this one doesn't have a proof, but you do have to know it and understand it. All right. So it says that an angle suspended by the diameter at the circumference of a circle is a right angle. All right. Here we have angle ABC. This angle is suspended by that chord AC. Do notice that that line passes through the center. It bisects that circle, so that means it's a diameter. So since this angle ABC suspended by the diameter, that means angle ABC is a right angle, meaning it's equals to 90 degrees. And then the converse or the opposite is that if you have any angle that is equals to 90 degrees, then whatever chord that is suspending it is a diameter. Okay, so let's check. ABC is 90. What's suspending it? It's suspended by chord AC. So that makes AC a diameter. So look out for that one. Either you are given an angle suspended by a diameter, then you know that angle is 90 degrees, or you will be given an angle that is equals to 90 degrees, then you look for a chord that's suspending it, and then the conclusion is that that chord is a diameter.